All right, this is our Chapter 3 warm-up. I'm going to do a couple problems similar to what we're going to see on the quiz. So let's go ahead and get started. This first one, A and B are parallel. So the first thing I want to do is mark everything I know. So A and B are parallel, and we know that angle 1 and angle 2 are congruent. Okay. Somehow I want to show C and D are congruent. C and D are parallel. And in order to do that, I'm going to have to use one of my converse theorems. So if you have your flip book, that would probably be really helpful. But let's go ahead and start with the first statement here, which is a no-brainer. But before I do that, I kind of want to think a little bit what I'm going to do. Okay. First of all, we know 1 and 2 are congruent. Well, we know 1 and 3 are going to be same side interior, so they're going to add up to 180 degrees. And if 1 and 3 are supplementary, then 2 and 3 must also be supplementary because we could replace 1 with 2. And since I can show these are supplementary, we can show that D and C are parallel by the converse of same side interior. So our first statement is the given information. We can sometimes do given information twice. So that's given. 1 and 3 are supplementary. This is going to be by the same side interior theorem. The book also calls it the postulate. We'll just keep using the word theorem just to keep it simple, which states if we have two lines that are parallel cut by a transversal, then same side are going to add to 180. Then what we can do is we can just say, well, if 1 and 3 are supplementary, then we know that 2 and 3 are supplementary. And the way we know that is I'm literally just replacing 1 with 2 because they're equal to each other. So this is called substitution property. And if 2 and 3 are supplementary, that means that our proof statement C is parallel to D by the converse of same side interior theorem. Okay? And that's pretty much all we have to do. Let's look at another problem. Okay, so here's our next proof. And what we want to do is we want to kind of look for a couple different things. So before we begin, we want to think about what we're doing. We're trying to prove A and B are parallel, so that means I automatically know. I'm actually just going to go ahead and do this right now. I'm going to write converse here because I know the only way to prove lines parallel are to use converse. I'm literally going to actually put that in. I know you should always think about it before, but this should help my thinking process. Okay? So let's go ahead and label some stuff. M is parallel to N, so we know that these are parallel. So we're just going to put little arrows, little additional parallel arrows on there. And then 6 and 12 are congruent. Okay, so we can actually attack this in a bunch of different ways. Now, it seems like they're showing that 6 and 14 are congruent. And so I want to somehow make it shown that 12 and 14 are congruent. So I think that's the path we're going to take. And if 6 is congruent to 14, and that means 14 must be congruent to 12, and we can use probably a converse there. So let's go ahead and get our statements in there. Angle 6 is congruent to angle 12, and M is parallel to N. That's all given information. 6 is congruent to 14. Well, the reason why I know that 6 and 14 are congruent is if they're sitting at a table, 6 and 14 are in the upper right corner, so that's going to be the corresponding angles theorem. We have to write theorem. And then I want to say that 12 is congruent to 14. And we know that because if you kind of look at the flow here, we see 6 is equal to 12. And then 6 is equal to 14, then we said 12 equals 14. So this is a form of substitution that we call transitive property, where we use 6 as a bridge to connect 12 and 14. So 12 and 14 were unrelated at first, and now we can relate them. So A is parallel to B. Well, since I showed that 12 and 14 are congruent, those two angles are alternate interior angles of A and B, so we're going to use the converse of AIA theorem. Okay? All right, let's do two more. Okay, here's another proof. I know, we're proof happy on this. So 5 and 7 add to 180. So we know that 5 and 7 add to 180. And we want to prove that these two, I'm sorry, not those two. These two are congruent. 5 and 6 are congruent. Okay, so let's go ahead and jump in to our first one, which is given. Given, given, given. They told us, we know it. And now we have to go ahead and develop how we're going to get to this idea. Okay? Well, we do know the relationship between 6 and 7 is going to be a linear pair. So we might be able to use that idea. So let's go ahead and see if that works. 6 and 7 equal 180. That's definition of linear pair. Again, we can use definitions. And then 5 plus 7 equals 6 plus 7. This one's kind of difficult to see, but let me see if I can show it to you. 5 plus 7 is this right here in green. And then 6 plus 7 is here in pink. And what you notice is they were both equal to 180. If they're both equal to 180, that means we can equal them to each other. So this is actually a form of substitution. Okay, we could even go ahead and call it, yeah, just substitution property. Okay, next we go from here to here. From here to here. How did I get this? Well, these aren't actually going from here to here. We're just stating that 7 equals 7. Well, of course that's true. That's just reflexive property. Okay, but then I'm really going from this step to this step. Notice that we subtracted the 7s from both sides to get 5 equals 6. That is called subtraction property. So that one's a little tricky. Okay? All right, last one. I promise it won't be a proof. Okay, for our last one, we have this picture here. We have 2x minus 7, 4y, and 84. And it says, find the values of x and y that make A parallel to B. Okay? Well, to make A parallel to B, we really need to set these two equal to each other because these two angles are alternate exterior angles. And if we have alternate exterior angles are congruent, then we can show that A is parallel to B by using the converse of alternate interior angles. The problem is that 4y and 2x minus 7 is impossible to solve. So you might be thinking like, this is too difficult to solve. Okay, so we don't know how to solve that. So what we're going to do instead is try and use this 84 degrees to help us solve for 4y, which we can in fact solve because 4y plus 84 should equal 180 because these are a linear pair. So we're going to go ahead and subtract 4y from both sides. This will leave us with 96 and then divide by 4. If we divide by 4, we're going to get what? I don't have my calculator on me. Here it is, even though I could probably do this decently in my head, but not super well. So y would equal 24 right there. So we can actually plug this in. Now we have 4 times 24, which is going to be 96. And now we can actually solve. So we have the y value is 24. And in here we plugged it in. Add 7 to 96. And we get 103, and then divide by 2, and x is going to equal 51.5. So that would ensure that we have parallel lines, and this was all by the converse of alternate exterior angles theorem. You're getting very sleepy. McDonald's.